Okay, so this is Spring 16, problem 44. This is a conceptual one. I'm not sure what the person who asked me this had, what their specific question was, but I'll just kind of try to explain it conceptually. And if you still have any questions, I am more than happy to, where'd my video go? I don't know. I'm more than happy to answer them. So we have a mass that's on a wire, it's a pendulum, and we are asked basically at what point is the centripetal acceleration maximum, and at what point is the angular acceleration maximum. Uh, so the maximum height of this thing is where it's at theta naught. So when theta equals theta naught, we're at our maximum height. Now, what do we know about that? Well, if we're at our maximum height, then we are not moving. And centripetal acceleration is v squared over r. Oh shoot, I miswrote this. I wrote the centripetal force. I wrote mv squared over r. So please disregard that m. That's a typo. The centripetal acceleration is v squared over r, and our v at the maximum height is 0. So we know that centripetal acceleration is not maximum here. Well, where would centripetal acceleration be maximum? It would be maximum where kinetic energy is maximum. So if I let this go, it's going to go here. Then its kinetic energy, all of its potential energy that it can convert into kinetic energy will be kinetic energy. And then as it's going back up again, it's going to gain potential energy and lose kinetic energy. So it's going at its fastest here. And that means that the centripetal acceleration is maximum when theta equals 0. The other question is, where is the angular acceleration maximum? And well, the angular acceleration is related to the tangential acceleration, which is to say, when is it going to be getting faster, the fastest? Yeah, so young modulus is also on 32, somebody pointed out. So yeah, so that's correct. So you guys don't need to do that because that's part of the units that aren't covered. So anyway, the angular acceleration is going to be maximum when the torque is maximum. And well, what's the torque? Well, the torque is going to be the force applied times the distance from the pivot, which is L, times sine theta, because we have to pick out the perpendicular component. And in any case, the formula is mgl sine theta, and this is going to be maximum when theta is maximum, and theta naught is our point of maximum angle. And so therefore, the torque is the largest here. And so the answer is that alpha is max when theta equals theta naught, and centripetal acceleration is max when theta equals 0. And again, just to correct my sloppiness, this what mv squared over L would be centripetal force. Centripetal acceleration is just obviously v squared over L, where L is the length.